Buried here, under the Greenlandic ice sheet, is an abandoned, nuclear-powered military base, built in secret by the US Army in Danish territory. And remarkably, we have hundreds of pages of declassified documents and footage detailing the construction of this base, which we have used to create this model of the facility. Today, it's hidden beneath 90 meters of snow, visible only to the surprise of ground radar scanning crews flying overhead, appearing as bewildering anomalous lines on their radar screens. These were the remnants of Project Iceworm. Project Iceworm was born from an imagined nightmare Cold War scenario, a secret nuclear missile silo that ensured mutual destruction, even in the event the continental United States was wiped out. But the apocalyptic logic that underpins it, and the military interest that has the United States government trying to buy Greenland for a second time, is still alive and well. This declassified document, titled "The Strategic Importance of Greenland," gives us some insight into the mindset of the United States as they began a mission to break international law for this project. In particular, this paragraph.
In 1950, the nuclear deterrent capability of NATO depended almost completely upon the manned Strategic Air Command bombers. Since at this time aircraft from USA bases could not reach any targets in the Soviet Union, and since Greenland is on the orthodone between the two superpowers, the need for air bases in the Arctic was very apparent.
To help fill this gap in NATO's capability, the United States was given permission by its NATO ally, Denmark, to build Thule Air Force Base. Thule, here on the eastern coast of Greenland, was, at its height, a massive operation involving 13,000 personnel, a hive of activity in an otherwise desolate region, keeping early warning radars and a fleet of B-47 Stratojets operational, allowing them to fly regular reconnaissance missions to Russia. That made it an ideal logistics hub for Project Iceworm. By air and sea, thousands of tons of construction materials and machines could arrive, where they were then dragged 240 kilometers inland by specialized Arctic tractor trains. Here, they go to work excavating the vast network of tunnels. Peter plows, based on snow millers used to clear avalanche snow from the Swiss Alps, were used to cut narrow trenches into the glacier. These things made short work of the ice, churning through 900 cubic meters per hour, throwing the excavated material over the sides of the trench like giant snowblowers, as other heavy machinery arrived to clear the debris. But simply digging a trench into the snow does not create a nuclear-powered missile base. They needed to put a roof on this structure. The workers used an undercutting technique which widened the trench floor by simply scraping off the walls at the bottom. This kept the top narrow, which would later be closed off with corrugated steel arches. Each trench was about 8 meters by 8 meters, with an additional half meter of snow filled in on top of the corrugated roof. Deeper trenches were worked in stages, with the Peter plows throwing their snow onto shelves cut into the ice above, which in turn would be plowed and thrown to the surface. It was difficult, uncertain work in one of the most brutal places on Earth. Here, temperatures regularly fall to -60 degrees. Not only is that enough to freeze skin in less than a minute, it's terrible for machines too. Kerosene for aircraft turns solid at that point. Diesels gel, as do most lubricants. Engines won't start up and hydraulic pistons seize up. Heated garages would have to be built directly into the snow to keep these machines operable. The sun disappears for a quarter of the year, and there's no shelter from Greenland's infamous Peterak winds that exceed 325 kilometers per hour, stronger than Category 5 hurricanes, or from the snowstorms that can smother the landscape in under 3 meters of snow in just 2 days. While this scale was never reached, the final goal of Project Iceworm called for tunnels 10 times the length of the London Underground, spread out over 130,000 square kilometers, an area larger than Greece, with 2,100 launch tubes scattered throughout, hosting 600 Minutemen intercontinental ballistic missiles that could shuttle around the hidden base on train tracks. In order to prevent a counterstrike, the Soviets would need to know the location of every single launch tube, and each blast wasted on an empty tube saves a more valuable target from destruction. Camp Century was a fraction of the size, designed to prove it could be done, from construction techniques to installing the first ever portable nuclear reactor under an ice sheet. This was a giant experiment. Over 16 months of construction, including through the constant Arctic darkness, a network of 26 tunnels totaling 3 kilometers in length were excavated. Each tunnel had its function, with buildings embedded inside to support the base or test its military capability. The longest line is 340 meters long, dubbed Main Street, and it branches into quarters for 225 men. A hospital, a library, a gym, a church and theatre, and railway tracks were even laid down inside to see how well they could move around missiles. The Minuteman mobility test train seen here is one effort to get it to work in the continental US. The train was intended to be the iceworm that the project took its name from, shuttling a nuclear missile around these hidden underground passages. But this project needed a special variant of the Minuteman, and Greenland's proximity to the Soviet Union allowed for modifications to better suit it to operate under the ice. They came up with the Iceman. This was not an intercontinental ballistic missile, it was an intermediate range missile, and that meant it could have one less stage than the Minuteman's 3-stage solid rockets, shortening the rocket considerably and making the process of rotating the missile into the vertical position under the ice considerably easier. The Iceman's warhead was going to be about twice as powerful as the Minuteman's. With a range of 5,300 kilometers, they would cover 80% of Soviet territory. But to keep the camp running and the missiles ready, a crew had to stay with them under the ice the entire time. The nearest city was over 1,500 kilometers away. This crew needed to eat, sleep, shower, and unwind under the ice. Living spaces were created from prefabricated wooden structures assembled inside the tunnels. The walls of these structures were separated from the ice walls to prevent the heat inside from conducting to the ice and melting it. Food and fresh personnel were flown in regularly, but otherwise the site had to remain self-sufficient. It was closer to living in a submarine than an army camp. When the US Army proposed this plan in 1960, they estimated this massive underground base would become operational within 3 years. Cost would be $2.4 billion, more than 5 times that of the USS Enterprise aircraft carrier launched that year. It took $400 million to run every year after that. From their perspective, it was a perfectly justified expense. The United States was in the middle of hallucinating a missile gap between NATO and the USSR, combining faulty CIA reports and JFK's election campaign rhetoric to conjure a vast Soviet arsenal of nuclear missiles that far outnumbers American ICBMs. Widely shared reports projected 500 ICBMs by 1961, rising to 1,500 by 1963, while the US would only have 130 by then. There was no way to defend against a Soviet first strike with so many missiles, so the only strategic option was deterrence with a reliable counter-strike. But how to assure it? The US Navy's solution was a fleet of submarines roaming the oceans. In 1960, they got a major upgrade. After spending billions of dollars, the Polaris submarine-launched ballistic missile was ready. It allowed Navy ballistic missile submarines to launch without breaking the surface, massively increasing their lethality. The Air Force had their B-52 bombers. They were fast, nuclear-armed, and could strike across 14,000 kilometers. So, Operation Chrome Dome was started. Fleets of B-52 bombers would fly non-stop from airfields around the world, so there'd always be some in the air if a nuclear war broke out. This kept up for 7 years, stopping only because the B-52s kept dropping live atomic bombs in accidents. But that's another matter. That left the Army, and they wanted to feel as big and mighty as the other branches too. Project Iceworm would be their ticket into the deterrence role, granting them the nuclear missiles they wanted and a fortress to deploy them from. However, the Danish had a policy of not provoking the Soviet Union right on its border, nor allowing nukes to be based on its territory. That would turn it into a prime target in case of a nuclear war, on top of heightening Cold War tensions, something made terrifically clear by the Cuban Missile Crisis in 1962, when the Soviets tried to smuggle missiles onto America's doorstep. And so, the US Army pinned their hopes on just keeping their work secret to avoid provoking the Soviet Union, which, if you think about for 5 seconds, you realize that's not how deterrence works. Trying to hide something this power-hungry demanded nuclear power. Anything else would require shipments of fuel too conspicuous to hide. But that didn't stop them from dragging these 110-ton tanks full of diesel to run its generators and machinery on a 70-hour journey across the Arctic to Camp Century. And so, they built this nuclear reactor inside tunnels of ice, which the Army documented in incredible detail in both film and this 164-page report. This was the PM-2A, the first portable nuclear reactor, a 1.5 megawatt nuclear reactor designed specifically to be transported in 37 containerized modules. It began to arrive at Thule during the final phase of construction aboard this ship. The whole operation really made me reconsider how complicated nuclear reactors actually are. A nuclear power plant is actually quite simple if you just ignore everything that can go wrong. You just need a nuclear heat source, in this case extremely high purity uranium-235, which you can see being handled here with all of the safety equipment the US military could afford. In order to use as compact a design as possible and allow them to be used for as long as possible between refuelings, these were 93% enriched uranium-235 cores. Modern commercial nuclear reactors use uranium enriched to a maximum of 5%. Each of these cores contain 500 grams of uranium-235, the rest was stainless steel, which makes this handling of the reactor cores even more concerning as a layman. But at this stage, these cores are just emitting alpha particles that pose little risk to your DNA. However, they are so enriched that just putting too many fuel rods close together would cause them to go critical. The team heading the project carefully monitored sensors and made calculations with slide rules to measure one very important factor.
Total U-235 content of the assembled core is 13.376 kilograms. Coefficient of reactivity 0.935.
See, even the US Army uses metric for all of the important stuff. That coefficient of reactivity is very important. When it reaches 1, the number of neutrons being released matches the number of neutrons needed to sustain the reaction. As long as it stays below 1, the reaction cannot sustain itself. So we need a way to control that number. Here, the engineers slowly place the cores into the reactor, taking note of their location on a piece of paper. And then, once everything appears safe, the control rods begin to be raised slowly while that coefficient of reactivity is monitored. Control rods are simply large blocks of material that are excellent at absorbing neutrons. Boron is the most commonly used material, but when it gets struck by a neutron, it splits into lithium and helium and can never be used again. It's gone forever. Not great for a secret nuclear base. So, in this case, they used europium oxide control rods. Europium is like the cat of control rods. It has multiple lives, absorbing neutron after neutron after neutron after neutron after neutron until it can't take any more and undergoes beta decay to become gadolinium-156. And as these control rods rise, the neutrons can finally reach the reactor cores and the number of fission reactions begins to rise.
Now here it is. With all 5 control rods withdrawn 6.24 inches, PM-2A went critical at 0652 hours.
Ah, shite, I thought we were going to have it all in metric units. That's 158.5 millimeters for the engineers in the room. Now that the core was critical, it was going to be creating a lot of steam, and from here, a nuclear reactor acts pretty much exactly like any power generator. The core heated a primary loop of highly radioactive high-pressure water, which exchanged its heat with a steam generator, which had a secondary closed loop of water which fed steam to a 1.5 megawatt turbine generator, before running to a condenser to be cooled back into liquid water. But all closed loops need a final exit for the heat, and this is typically done with an open loop water heat exchanger. So how do you solve that problem when you are surrounded by ice, not water? This actually posed a massive problem. Even melting the ice and using that wasn't an option. In the event of an accident, you couldn't run the risk of your coolant lines freezing, so water was out of the question. The outside temperature could get down to negative 60 degrees, so why not use air instead? 3 air blast chillers used electric motors to draw air over another closed-loop coolant line filled with glycol, which cooled the secondary closed-loop water line in the condenser. Incredibly, the engineers involved in this project underestimated the effect of thermal expansion during assembly. The glycol aluminium pipes were test-fitted in typical room temperatures, and assemblers on site had to leave the maximum allowable space between the ends of the pipes to get everything to fit because they shrunk so much in the Arctic. Again, This is a coolant line contaminated with radiation. This system didn't eliminate the wastewater problem altogether. Lines leak, pressure needs to be vented, and radiation isn't always bothered by physical barriers. They needed somewhere to dump all of the wastewater and sewage from this facility. They drilled a massive hole in the ground with steam and began dumping all of the wastewater, sewage, and radioactive waste into this giant reservoir. A reservoir of radioactive human waste that remains buried under Greenland to this day. What blows my mind most about all of this is that they were essentially building this entire base like an IKEA build-by-numbers kit. We get references to it in the declassified report.
The systems of match marking and simplified isometric drawings for reference were ideal.
Every piece had markings indicating where it belonged and what it would be connecting to. And incredibly, we have report after report of how this construction project went wrong. At one point, a shroud for an air blast cooler was put on backwards because the markings were printed incorrectly. We also got reports of how the control rod racks weren't straight and had to be manually straightened with a blowtorch and a wet cloth. Incredible craftsmanship, but still worrying. The PM-2A was the real objective of Camp Century. This was an incredibly advanced experimental nuclear power plant, the first ever to be fully constructed out of parts shipped through standard army logistic chains. But this was a ridiculously dangerous design that could go supercritical with some very basic mistakes. That exact thing happened with the SL-1, another product of the Army nuclear power program, in 1961, when an operator had a little whoopsie and pulled a control rod out 4 times the distance that was required and caused the entire cooling pool to explode instantly as superheated steam. That accident killed 3 people that had to be buried in lead coffins because their bodies were so radioactive. But that never came to pass for Camp Century. That accident taught the Army nuclear power program that the reactor shouldn't exceed that 0.935 coefficient of reactivity number even if one control rod is fully withdrawn. It would only go critical if someone managed to pull out a second rod too far. Something else brought Camp Century to its knees. After 33 months of operation, from first criticality in October 1960 to July 1963, the reactor was shut down. What defeated it, and what ended Project Iceworm, was not cost, technical difficulty, or even political pressure. It was the very ice they relied upon. Greenland's glaciers moved faster than expected, so they would gradually crush the tunnels in their path in a matter of years instead of decades. This is what they looked like in 1961, and here they are just 4 years later. The only way around this problem was to basically rebuild the entire camp every 2 years. Camp Century staff were already forced to shave nearly 2 meters of ice off the walls of their reactor room to prevent the equipment inside from being mangled. It might have been feasible for a small research project to sustain itself this way, but the US Army balked at the idea of having to do this for the full-scale Project Iceworm across thousands of kilometers. There was no way they'd put sensitive strategic capability at the mercy of collapsing tunnels and bent railways. So, in 1966, Camp Century was shut down, and by 1967, it was abandoned. The nuclear reactor, along with its radioactive fuel, was removed. But that cavern in the ice remained, filled with 24 million litres of radioactive human sewage, along with 200,000 litres of diesel fuel, all sealed inside the ice. In 2024, NASA got a glimpse of the buried ecological disaster with a Gulfstream equipped with a synthetic aperture radar pod. It has drifted 90 meters under the ice, and while its creators assumed this would be an ice tomb it could never escape, that very same Gulfstream was sent to measure the accelerating movements of the ice sheet. It's expected that this buried ecological disaster will resurface in 100 years. No one has attempted to create large-scale installations under ice since Project Iceworm, as far as we know. The Danish government didn't even know Camp Century's true purpose until 1996, when it was declassified. Despite the pre-roll of this declassified film stating it was done with the cooperation of the Danish government, and despite recent geopolitical controversy, the US military still operates in Greenland. I myself flew into Camp Raven aboard a ski-equipped LC-130 on a resupply mission to researchers. We made an entire video about that trip that you can watch. And Thule is still there, now called the Bootyfeek Space Base. helping track the missile threats that it was once trying to pose. We've created a new show using an incredible new animation technique we developed with Lumafield, whose industrial scanners allow us to create these volumetric models of anything we can fit inside, allowing us to explore every hidden nook and cranny of some of the most intricate devices ever conceived. This week we explore the Nokia 3310, exploring how its rugged, cheap, and yet incredibly innovative design revolutionized mobile phones. Exploring these CT scans was just so visually stimulating, we knew we needed to make a full series using this new technique we developed. And with the help of Nebula, we hired a new animator with a background in electronic engineering to take the technique we developed and help us make one of these videos every month. Next month, we will be breaking down the incredible first-generation iPod, which has a surprising amount of electromechanical devices inside. This series is available exclusively to Nebula subscribers. A monthly subscription is just $6, but with my link or the QR code on screen right now, you can get an entire year's membership for just $30. That's $250 a month. We are currently running the show as a pilot, so if you want to see more of it, you gotta sign up now. Or, if you are sick of signing up to new subscription services like I am, we've created a lifetime membership, if you would rather just pay it and forget it. In a time when creative work is getting harder and harder to find, Nebula helped me hire a young, talented animator and create a new series. That's what Nebula is about, supporting creative work made by humans.